Dahnaya Joyner is a software engineer with over 7 years of experience specializing in front-end development. Her passion for coding extends beyond just writing code. She loves teaching and mentoring others to grow their skills. She's had the privilege of working as an instructor and tutor, helping aspiring and current developers navigate the complexities of web development. And our second speaker, Poulami Saha, is a senior software engineer at DeliveryHero, specializing in front-end development after transitioning from full stack over the last 5 years. In addition to her work, she is a tech blogger, enjoys spending time with her toddler, and has a passion for food. It's an honor to have you both with us today, and the stage is all yours.
Thank you, Violina, for the wonderful introduction. Happy New Year to everyone who is there in the call, and I welcome you all once again to this amazing session with the Beginner's JavaScript. This is the second last session, to be honest, but yes, based on this one was just the beginner one, so I think Frontend Queens will also arrange one for the advanced level as well. So I will start sharing my desktop. And is my presentation visible on Asynchronous JavaScript? Yes. And the code now? That's true. Okay, fine. So in this session today, we will be talking mostly about the asynchronous JavaScript first, and then Dahnaya will follow up with the promises, the API and the course. So just before starting with asynchronous JavaScript, I just want to give you the agenda a bit, like what are the topics that we will be covering over here. The callback function, hell, inversion of control, promises, promise chain, async await. These are all the things, terminologies that we normally hear when we talk about asynchronous JavaScript. Now, starting with the definition of what is asynchronous JavaScript, we should first also recapitulate what is synchronous JavaScript, because that will help us understand what is asynchronous JavaScript. So let's go to the code base first. So over here, I will just comment out this and uncomment this part. So a small heads up over here, like as we know, unlike Java, JavaScript is a single-threaded program. That means it has only one main thread, and that is the thread that controls. It doesn't support multiple threading at the same time. That means it doesn't have multiple main threads, but it does asynchronous programming. How? So over here, if you see these 3 lines of code, when a JavaScript engine parses this code, it goes from top to bottom. So over here, what it does is like, it will first execute line number 2, then number 4, then number 6. And if we see how it goes, we can see it over here. That it first printed start, then it printed synchronous operation to be handled here, and it ended. What if any one of these console takes a bit longer than expected? Will JavaScript wait for that particular line and hold on till that line completes, or will it go forward? And here comes, let's see how it works out over here. So this is a very common example of asynchronous. To explain what is asynchronous, like over here in the code, we have console.log start. So we can read that, okay, it will first complete the start. Then we have a set timeout operation where we want this console to get printed after 2 seconds, or rather 2000 milliseconds. And over here it is console.log end. Now, if we see what happens over here, I will just clear the output. And over here, if I run this code, over here, as you can see, like first we have start, we have end. And then only after 2 seconds, this sentence got printed. So which clearly indicates that in spite JavaScript being a single-threaded program, it didn't wait for this line to execute. What it did, as soon as it identified that this line will take a longer to proceed, it just took it out of the execution stack, that is its main thread, put it into a separate queue, and it moved on. It moved on to whatever was there left for the program to execute. Only once the asynchronous operation, or the one that took time, got over, it pulled it back to the execution stack from the queue, and then it got it printed over here. This is the concept of asynchronous JavaScript, where we say that Though the program is written this way, but it didn't wait for anyone. It just went on synchronously. Whatever took time, it just moved it out of the execution stack for the time being. So over here, this is a very common thing. So let's see how we can define it. So the definition exactly says that it enables the non-blocking operations, allowing tasks to run in the background without freezing the main thread. So as we have seen, we didn't freeze the main thread. We just put it out in the execution, out of the execution stack. And only once it got complete, we pulled it back. And what are the most common examples? Where do we use normally? The thing that fetching data from an API. We will dive deep more into the APIs in the next part of this session. So there, when the API takes a bit longer than expected, then reading files. Suppose we are just reading files from an external source. It may take some time to read all the files. Or the event listeners, especially when we are doing the DOM manipulations, the click event, the hover event, whatever event it just takes a bit more time than normal. Next comes the callback. So as you can see over here, in the set timeout, we had a function that was passed, and we expected that after 2000 milliseconds, that function will get executed. And what is this function? This is nothing but a callback function. So as we know, that callback function is nothing but a function that is passed as a parameter to another function, which is very common in JavaScript. That's a callback function. So over here, we can see an example for a callback function. So let's come to a more practical example. Since from here, this callback topic, we will be starting more practical examples on asynchronous JavaScript. From here, we start with an example of an e-commerce website. So that's very normal. Every e-commerce website does the same thing. So it first, suppose we say that, okay, we are submitting, or we're confirming that, okay, we are placing the order. So once we place the order, it does all the required validations for the order, like whether everything is perfect or not. And once the order is placed successfully, it gets navigated to the payment section. So consider that payment and place order is being handled by two different teams. So how is it done over here? So when we are calling this place order function, we also pass a callback function to it. And what does that callback function does? We say, okay, once the order is placed, just navigate to the payment section. So over here, we have done, say, okay, after 1 second, I'm considering that within 1 second, all the order validations will be done. After that, you just kind of get yourself navigated to the payments part. So over here, we can see how it looks. So after 1 second, we say that, okay, order placed and proceeding to the payment. That means this is the function, this is the callback function that helped us with this asynchronous operation. So with this comes another topic, that is the callback hell. Now, why we are not so much interested with callback functions over here in asynchronous operations? Consider that I have these separate functions, which is place order, process payment, display order details, update the order history. And all of them will be, I'm considering all of them takes around 1 second to complete in the sequential order. So how does it look in a final operation? So first we place the order, and we say, once the order is being placed, we proceed to payment. And once the payment is being done, we show the final order details, that what has been ordered. And once that is done, we also update the order history. So this is a normal operation that we do. If we follow the callback approach, then we can see that this code is gradually increasing horizontally. One after the other, it's a horizontal increase, and the code is not increasing vertically. And another thing, if you notice this triangle over here, the triangle that got created, this is called the pyramid of doom. In callback operations, this triangle is inevitable. However we write it, it will constantly increase horizontally, and this triangle will also increase. And this triangle will increase both in length and width, because over here, we have only just made this, we haven't handled our errors or anything just to keep the code simple. Just imagine our original e-commerce website application. If this is handled this way, then how big this pyramid of doom will be. So this is the drawback of callback hell. So if we go into the slides, back to the slides. So the nested callbacks that makes the code hard to read, debug, and maintain. This is what we have seen in the callback help. Because over here, you can imagine, like, if something has failed, it's very difficult to track in which callback operation this has failed. Or how do we know that which operation has failed? It's very difficult to maintain at the same time because the code will constantly increase this way. So next we have is the inversion of control. Inversion of control is, consider this particular example and imagine like each of these operations are being handled by different teams. So over here we can see 4 teams have been involved. So the place order team is calling the main function and it's totally relying on process payment to process the payment. Now process payment will rely on display of order details. So what over here happens, we lose the control from the code. Like I don't know, like if I am the main controller of the code, I don't know whether the process payment have really been called or not because I have given my code to place order. So I'm totally unaware if the process payment has been called or not, whether it has been called once or more than once, or is it just a free product that is being delivered, like process payment was mistakenly not called at all. So I have lost all control from this code. So this is what we call as inversion of control, like we lose the control from the code base. So these are the drawbacks mostly we have from the callback operation over here. Because if these codes depends on it's a owner of different teams, we can't just go randomly and say that, hey, can you figure out like if the payment was done or not, if the order details were being displayed correctly or not, or is it shown like a person has ordered only one item but in the order history it is being showing that the person has bought 2 items. So these type of mismatches happens. So that is what we call the risk inversion of control. So to avoid all these things, we have another solution to this problem, and here comes the showstopper, that is the promise. So what is a promise actually? A promise in JavaScript is an object. I will read this out from the MDN documentation itself. So it might be a bit overwhelming at the beginning, but I'll try to explain it as much as possible. So promise in JavaScript is an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. It acts as a placeholder for a value that may not be available yet, but will be resolved or rejected in the future. So as we have all seen, like in asynchronous operation, there is an uncertainty. We don't know when that particular operation is going to get completed. So that's the reason why promise is actually, we have an empty object. Just imagine it's a plain empty object. And the data inside that empty object will be filled in due course of time when that particular operation is completed. And what are those data in that empty object? The resolved or the rejected value. A promise will either get resolved or a promise will get rejected. That means consider that an order will either get placed or it will return an order ID, or it will get rejected and it will say that sorry, we couldn't place your order. There is no other option that is available from that place order operation. So over here, what we will get is the current status, like whether it is in the pending state, like is the order placement process still in pending? Is it fulfilled, or it will be fulfilled once we get a valid order ID? It will be in a rejected state if we say that, okay, no, we couldn't place the order. So these are the things that gets filled up in the object that promise creates. And it's much easier for the error handling. As you have seen in the callback hell, in the pyramid of doom, it's very difficult to handle the individual errors. But over here, it will be easier. So we will see it more in the code. So next we have some of the key characteristics. So as I said, that promise can have only 3 states. One is pending, one is fulfilled, one is rejected. That is, for an example, consider an order placement is in the process of being placed. Order has been placed and the order has been rejected. And next is the chaining. Like in promise also we can, unlike just like callback functions, in promise also we can chain operations. Like we have the first we will complete the place order, then we will go to the payments, then after that we will be going to the details, and then finally we will update the history. So one after the other we can do the process as well. And next is immutability. With promise, the thing is that we can never change the value that is being resolved by or rejected by a promise. Whatever the value the promise returns is the final, it's immutable, we cannot change it. So let's see how promise looks actually. So over here, promise, just before proceeding further, we have two parts in promise. One is promise creation and one is promise consumption. So first, let's start with promise consumption. Then we will go into promise creation. That will be a bit easier, the other way around. So considering the example place order, over here, just imagine that place order was a promise. And once that place order promise is resolved, JavaScript comes with this then. Then will get executed only once place order is resolved or rejected. So after that, we will go to process to payment. Sorry for the interruption. Once the payment has been processed, then we will go to display order details. And only after that, we will go to update order history. And then we will say like, okay, all the steps has been completed. And if anything fails in between, we will be catching the error over here. So this is the place where we are consuming a promise. Now let's go a bit deep into where we are creating a promise. So over here, this is the place order. And over here is the function that is creating a promise. So consider we are now the place order team who is creating the operation of this place order. So what they have done, over here, JavaScript comes with this promise constructor. And this promise constructor inside takes a callback function. And what does it do? It has to resolve and reject. That particular callback function takes two parameters, resolve and reject. So a promise, when it gets over here, consider before this set timeout over here, we will be doing all the validations for placing the order. So like whether the order is properly placed or not, we will place the order, we'll store the order in the certain database and everything. All these processes will get completed. And only once it's complete, we will say, okay, now you can resolve. Resolve means you are considering that your execution, your asynchronous operation is now over. And over with a positive note. So everything went well. So you are now resolving it. You can pass any values in this result. Maybe over here in this instance, we can pass the order ID. What is the resultant order ID? It can be a single value, it can be an object, it can be anything that can be resolved. Resolved is nothing but the return value of the promise. And in case something fails, we can use reject. So resolve and reject are the two exit conditions for the promise operation. That was the asynchronous operation that was being under process inside the promise. So over here, what it does, it returns at the order promise. So over here, we created this new promise and we consider it into a variable. We put it into a variable and now we are just returning the order promise. Similar we have done for the process payment as well. This team also created a new promise for us. And then they did all the payment related stuff, all the payments and the gateways. They have handled everything properly. The payment is complete. And then they are saying, okay, the payment is done. So they can also, I haven't returned anything over there, but the payment team can also return as the payment ID to the actual caller of the function. So this is what this promise is all about, like the creation part. So how this code now works. So as soon as JavaScript engine executes this code place order, what it does is indirectly it creates an empty object. And over here, just consider the data is being undefined or the result is undefined and the status is in the pending state. So what happens over the period of time, this place order, as soon as the place order gets resolved, this data gets replaced with the order ID. If it is a successful, means if the resolve has been called and the status becomes fulfilled. But in case that it happens that the order couldn't be placed, over the period of time, this order ID will get like order failed or something, whatever is being given in the team has decided to return in case the order fails. And here the status will be rejected. So what happens? JavaScript engine just reads through the code line by line. It went to place order and it has seen that, okay, this is a promise. This will take some time. Okay, I will just took it out of the main execution step or the main thread. Once the place order is being resolved, then it will again put it back to the execution stack, and then only, and only then it will start executing the next step. That is okay. Then what will I do? With the ID that I have received, in case if I would have returned an ID from the place order, with that ID, I will be calling the process to payment. And then it will figure out that, okay, process payment returns me another promise. Okay, now you again go back to the out of the stack. Once the process payment has completed, then it will again pull it back to the execution stack and display the order details. Not a single piece of code will wait over here. JavaScript engine will not wait at any line over here. As soon as it will figure out that it is an asynchronous operation, it will take it out of the main stack and will continue with the rest of the code. So normally in e-commerce website, they're super fast, as we have seen. But still, if something is still in progress, we see a spinner running. That means we are still waiting for the response, because it just can't let us go out of the page and do anything else, but it keeps the spinner running to show that, okay, something is in progress. But to be honest, they are super fast. But that is how the JavaScript code works. Like any asynchronous operation, it never holds on, it never waits. Now, one thing is like with promise, it will only resolve once and then will get executed only once. This is the assurity that promise return gives us. It will never happen that place order by mistake, it will trigger process payment twice. It can never happen. As soon as once this line of code gets executed, it will never re-execute it again in any scenario. It will just proceed to the next one. So this is over here, what the benefit is that there is no inversion of control. The entire control is there with the caller. If I am the caller function, if I am the person who is handling all these different squads, different teams who is working on this, I know each team, once the order team has placed the order, they have returned me the order ID. So their job is done. It's me who is then calling the process payment with that order ID. Once they are done, they will also return me their payment ID. The order ID and the payment ID, I will send to the display order details team. So the control is totally on me now, on the caller side. So this is what the most benefit of promise. So over here, as you can see, that promise chaining. So as I mentioned earlier, like one after the other, we have so many promises being called. This over here, as we can see, the code is no longer going horizontally. The code is going vertically. And also how we can handle this error over here. For the time being, I have just written the catch at the end. That means any steps fail ahead, like place order, process payment, display, anyone fails, it will get catched over here, that an error occurred. But over here, each then can be accompanied by its own catch. Like whenever, if I write a catch over here, any error that happens on top of this then will get catched over there. So it's a totally dedicated to place order and process payment. If I write after display order details, it will be dedicated to only display order details, because this catch will handle the one on top of it. And over here, if I write it, this catch will handle only the one that error happens in display order details. So it is very easy to debug compared to the callback operation that we have seen earlier. So if I just run this code to show how it looks now, see, order placed. After 1 second, we say, okay, the payment has been processed. After 1 second, the order details has been displayed and the order history is updated. So this promise, which is actually both a consumer and it has a construction phase or the creation phase and a consumption phase as well. So, and this is what that makes promise a bit difficult to deal in day-to-day application is like, I don't know when my promise will get executed. So often what we miss is like, we just try to use the value of this placeholder, or whatever there's a response from this entire operation, even before this operation is complete. That's a very common mistake which developers always do if they don't understand the play or promise concept clearly. So always remember, promise is not something that will get executed immediately. It will always get executed sometime in future, and we never know what is that time in the future. So the rest of the code should be handled accordingly. So after promise chaining, over here we have another option, async and await. So as in the last just a second before I said it's very difficult to predict that when my operation will get over or when the promise will get resolved and how to handle the code, how many then should I be writing? JavaScript in the latest versions has come up with a better approach where it still handles promise, it's still asynchronous, but it will just makes us feel like synchronous. So it's nothing but a syntactic sugar built on promises for writing asynchronous code that just looks synchronous. It's just cleaner and more readable and easier to debug, but it needs modern JavaScript. It's not handled with the older versions. And one drawback is that it doesn't handle promise.all. So before proceeding, I will just say what is promise.all. Consider we have over here, we are having only place order. Consider we have two more operations, place order, an order has been placed, or two more services that works at the same time. So what we will be doing, like we need to wait for all those three to complete before proceeding to press the payment section. So promise.all is a concept in JavaScript where on the then will get resolved. The first then will get resolved only when all the promises that are being there in the array. Consider over here, we have an array of promises that we want to place over here. When all of them gets completed, then only the result will be resolved. So this feature is currently not supported with async await. Let's see how we can resolve this example in async and await. So over here, as we can see, we have the same program, the same promises that are being created just as before. And how are we dealing with it? So over here in async await, a function that is the execute order. Consider I have wrapped everything into an execute order function. This execute order function has to be called with the keyword async, which clearly specifies that this is a source of an asynchronous operation. And now, each time there is a promise, we will be writing an await in front of it. So what does an await do? An await makes the JavaScript to stop over here. Like we have said last time that it waits for it till to get to resolve or rejected and then only then gets executed. Over here, we don't write then, instead we write await. So await will return us the result of the resolved or the rejected placeholder operation. Sorry, place order operation. And only once this order is being placed, we will be calling the process payment. And again, the JavaScript, it shows us that it is waiting over there. Yes, I'm awaiting for this operation to complete. Next again over here. So only all these things are now, if we look into this code, it makes it more readable and it looks like, okay, it's a synchronous operation now. This will get executed only once this line is over. We will proceed to the next line over here in the await. Once process payment is over, then only we will navigate to display order details and then only we will proceed to update order history. It is just a syntactic sugar. In original JavaScript never waits with any of this asynchronous operation. It just takes them out of the call stack, execution stack, or rather what we call. But over here, when we are seeing the code visually, it looks much more synchronous. So over here, as you can see that this is how it looks like in async await. The similar thing when we have done for promise, this is how it looks. I think we are just gradually increasing the number of lines as we are going back. And if we go it with callback, then I haven't written the full one, but we can imagine like how it will be expanding. So I'll come back to async await once again, and we'll go through the slides a bit. So this is all that I had from my part in this promise. This is the official documentation of the MDN documentation and the GitHub repository. I will share with you the presentation link in the chat. Yeah, so any questions for me?
Hi, I just wanted to say this is way over my head, but honestly, I love the way you explained it. I understood what you were talking about while you were talking about it. Could I do it myself? Probably not yet, but I really loved the way you explained it. That's just I wanted to say thank you.
Yes, thank you, Maria. Promise is a topic that it's very hard for someone to grab within 30 minutes. To be honest, I myself is still struggling with promise for the last 5 years. And the thing is like, only thing that I can suggest you is like, there are now numerous videos on YouTube, or you can see it over any tutorials, online platforms. I will just say, just go through those videos again and again, because promise is really a very difficult thing to grab and to write as well at the same time. So, yeah, I wish you all the best with this one. And feel free to ping me anytime you find any difficulty in understanding. I am available in the Frontend Queens Slack channel. So, yeah, I will stop sharing and over to you, Dahnaya.
Thank you. That was a great presentation. And now I'm going to be talking about APIs in JavaScript, fetching, manipulating, and handling data. And my name is Dahnaya Joyner. I'm a senior software engineer. All right. So on the agenda, just gonna name a few things. We're gonna talk about everything, but we're going to talk about what is an API, understanding RESTful APIs, fetching and manipulating data, and best practices. So, what is an API? An application programming interface, or API, is a set of rules and protocols that allows one software application to communicate with another. Sorry, one second. It defines the methods and data formats programs can use to request and exchange information. So the purpose of an API, for one, is to bridge the gap. They allow different application systems or services to work together seamlessly. It helps with efficiency. Developers can leverage API so that they're not reinventing the wheel, essentially. And it allows for standardization, which it provides a consistent way for applications to communicate, ensuring predictable results. So let's look at a real world example. So on the bottom, we have a restaurant, right? So we have the customer, and the customer is going to look at the menu to see all of the available options. And then they're going to tell the waiter their order. So, chicken sandwich, no onions, no pickles, honey mustard. And then the waiter is going to give that order to the kitchen. And the chef is going to make the food. Then the kitchen gives the waiter back their food. And then the waiter then gives the customer the food that they requested, hopefully exactly how they requested it. So similarly, with an API, we have the end user with the browser, so the client. And as you can see, they're looking at the API documentation that tells them everything that's available to them. And then they're going to give that request to the API. And then the API is going to send that to the server. The server is going to respond and send the response to the API, which it then sends the response to the end user. So the API can be seen as the waiter in terms of the restaurant. They both act as the middleman from the client or the patron to the back end. And so just like with the restaurant, you don't need to know how the kitchen cooks the food. You also don't need to know how the API's backend works. Like you're probably never gonna go to the kitchen and just tell the chef like exactly what you want. You have to have something in between that speaks both languages. So standardized communication. So you make requests in a specific format, ordering from the menu, and the response is predictable, aka your food being prepared as you described it. Efficiency and scalability. APIs let developers reuse services, and it reduces development time and effort. And we see APIs every day. So like a weather app, Google Maps, payment systems. Whenever you go to checkout, if you see like pay with PayPal, that is using PayPal's API. And this goes back to efficiency. Sure, the site could create their own payment service, but why do that, and why waste all that manpower if there are other services already that do exactly what you want? Types of APIs, we have GraphQL. It's a query language that allows clients to request only the data they need, providing more flexibility and reducing overfetching. SOAP APIs, Simple Object Access Protocol, a protocol-based API that uses XML for structured messaging, often used in enterprise applications requiring strict standards and security. And we have REST APIs, representational state transfer, a lightweight stateless API architecture that uses standard HTTP methods like get, post, put, delete, and URLs to access and manipulate resources. And today we're just going to be focusing on REST APIs, and you'll often hear them referred to as RESTful APIs. So here are the HTTP methods. With RESTful APIs, you have GET, which you make that request when you want to retrieve data. POST request submits new data or creates data. Put and patch, both requests update existing data, but with put, it's used when you want to completely update a resource or a record. For example, if you want to update a user's email, phone number, address, you would use put. You would use patch when you want to update a single field or just a few fields for a resource. So, for example, if you want to update the number of people for a user's reservation, instead of just updating the entire reservation, you would use patch. And then, of course, we have delete, which will remove or delete your data. Getting data from API, so making a GET request. So we have the fetch method, which is built in to JavaScript, and fetch makes HTTP requests. And then, as we just saw, we have promises and promise chaining. So .then handles the response asynchronously, and JSON parses the response body. So JSON it stands for JavaScript Object Notation. It's universal in terms of data exchange. Parsing the response body means converting the raw data received from a server, typically in JSON, XML, or plain text format, into a format that your application can work with, like a JavaScript object. This process allows you to extract and manipulate the data easily. And when you make a fetch request to an API, the response body is typically returned as a readable stream. And so that data isn't directly usable, so then it needs to be processed into a format your code can work with, like JSON. So let's look at dummy JSON / users. First, let's look at what that looks like. So if you go directly to the site, you can see all of the users, first name, last name, and all of the properties that come with it. So how would you get this data in your code? we do something like this. So you fetch it, you pass in the URL, waits for the response, you convert that to JSON, and then you get your data and you can log it. So here we can see all of the data that we just saw, all the properties, it's the same thing. So data itself will give us this: users, total, skip limit. We don't need all of that right now. So since I want to just access users, I will just put .users and it gives me all the users back. So this is how you would use fetch to get data. And so something like dummyjson.com/users you can use like when you're making a site and you just need some dummy data, some user data. I believe they also have like /products and other things that is easily accessible for you. Yeah, so this is an example of a post request. We passed in the URL, but as you can see here, we specify that the method is post. We're passing, when we make this request, we're passing in a body and we have headers. So for the body, we define the data to send. And then we have JSON.stringify. I have first name Jane. First name was a property of the user. So you have to make sure that your properties match what the API is expecting. So, and then it converts the JavaScript object into a JSON string because APIs typically expect data in JSON format. And then we have headers, which are metadata for the request. Content type informs the server that the data sent is in JSON format. And so you'll notice that we didn't specify get here, but we had to specify post here. So that's because when using the fetch method in JavaScript, get is the default. So you don't have to specify it. But when you are doing other requests like post, put, patch, delete, you will have to specify that. Manipulating API data. So this is an essential skill, knowing how to manipulate data for engineers. But as a front-end engineer, a lot of my job is to basically fetch data and then display it in a desired way. It's like an oversimplification, but essentially that's what I do. And so in this example, I'm getting all of the users, and then I'm printing out an array of just the ages. So if that's your feature, if that's your task, if that's what your client wants you to do, you have to be able to find a way to be able to just print out all of the ages from the users that you get back. So here we're using map, and if you recall, map returns a new array based on like what you the parameters that you give it. So here I want a new array of all of the ages. So let's see what that looks like. So passed in the URL, so we got the data. And then now I'm manipulating the data. I want to only get all of the users' ages. And then when I console log it, here we have an array of all of the users' ages. So this is just one way of one way to manipulate data using map or like filter and different methods like that. Another example is, let's say you need the total of something. So if you have like products, you might need the total of the items in a cart. In this example, we have ages. So let's say we need the total age. Because most likely you're not going to be able to get like data dot total age from the back end. A lot of times they, want you to do that on the front end. And so here we're using the reduce method to add up all of the users' ages. So if we look at that example, yeah, we can see total age is 977. So we got the data and now we, manipulate it. And so we use the reduce method for every user, we add up their age, and yeah, that's how we got 977. And to really drive home the point, another example is if you need to format user data. So maybe you don't need all of the properties that they gave you, like that had like 20 different properties. Maybe you just need the name and the age, and that is in a format that is easier to use. You may need to display your data in a clean, readable format. And this could involve combining first name and last names or calculating ages. So here, again, we get the data, and now I'm saying like I only want an object that has the name and age. And so we don't have a full name property. So here I have to manipulate the data and create the full name using the first name and the last name using interpolation. And then we do have the age, but let's just say, we're calculating the age just using the birth date. And JavaScript comes with this date constructor. And so it allows you to get the full year of the current year minus the year of if you pass something in, it'll give you that full year. So it's doing the current year minus the year that that person was born. And then that is how the age is calculated. So let's see that in action. All right, as you can see, we still have 30, right? We had 30 users. We still have 30 users, but now it's just more readable. And if for whatever reason I just need the name and age, now I can just say, user.age, user.name instead of user.first name plus user.last name. It just makes things a lot more readable and easier to work with. So when we make API calls, errors may happen and we have to be able to handle those errors. So we have try catch, which the try block. So JavaScript will attempt to run the code inside this block. And if no errors occur, then the catch block is skipped. And if an error does occur during the execution of the try block, and JavaScript will immediately jump to the catch block, and that receives the error object, and it contains information about what went wrong. Some best practices for API calls: we have rate limiting, caching, security, validation. So rate limiting is you want to avoid making too many requests too quickly. Caching, you store frequent data locally. Or you can, for security, you can use API keys and HTTPS, and there's validation, and that is when you always validate and sanitize user inputs. So just for an example of what one of those looks like, we have rate limiting, request count, and then we have max requests, which is 5. And so we're basically saying here, if the request count is less than the max request, then, do this. And then once that is not true, then we go in the else block and we say, rate limit is reached. And so you want to avoid making too many requests in a short period to prevent overwhelming the server. And many APIs impose rate limits like 100 requests per minute because you don't want to crash. And yeah, so that is, so here's a recap of all the key points. We learned what APIs are. We learned HTTP methods, how to fetch and manipulate data, error handling, and some best practices. And any questions? All right, thank you.
Amazing. It was really helpful, and Dahnaya, as always, you delivered the session in a very good way. And now it's time for cross-origin resource sharing or course. And again, Poulami, the stage is yours.
Yes, thank you, Violina. So, yeah. So this is a very small topic. I don't have a definite code snippet for this one to show today, but considering what it's a continuation of what Dana has said, that API calls. So often we happen that we get to see this error in the browser. So CORS is nothing, the full form is cross-origin resource sharing, and why do we need it? The biggest question. So it's a security feature from the browsers, like it prevents a website from making requests to a different origin. Like as you have seen, Dana showed that we are calling a fetch API. So consider you have created an application and you want to fetch the data from another source, and that the originator source, that is the one your application, and the one from where you are fetching the data, they have a different domain, different protocol, or a different port than its own. That is from the caller one. It will definitely block. Browser will block this request. And what it says, like, how can it be different? Consider I'm calling it from http://example.com, and I'm calling to api.example.com. So over here, what happens? They two are not of the same origin. They have two different origin, and browser will block this one. So it's a mechanism that allows restricted resources on a web page to be requested from another domain outside the originating domain. So, and what do we need? Why do we exactly need? Means why the browser does it. First, what it happens is like, mostly it's a security feature, and how can we overtake this one? So what happens when the first API call is being made, the browser sends a pre-flight request with the options and to the server, that is the address where we are being currently fetching. And the server then first figures out that whether the call is coming from a legitimate point or not. Like suppose you are having some important data about a certain service or something, you just can't randomly share the data with someone else, even if they have the proper valid credentials or not. First, it has to happen that you are being called from a legitimate source. So it verifies if the server permits the actual request. And then does the request comes with the actual original headers, the contract that has been set between the browser, that is the front-end application, and the back-end application. Like, okay, when I will be asking you for a data, I will be asking you with some certain headers, if any of the header is missing or not. Now, if it is a legitimate requester, then what returns the server returns? The server adds these three headers in the request itself. And it comes in the response header from the server to the browser. It says that the first one is the access control allow origin, which specifies the allowed origins. Like, yes, I allow you as a requester to fetch data from my side. It also allows the methods, like which particular methods are being accessed. Like the server can say that, okay, I only returns get and post request results. I don't allow delete and put. So if it doesn't have delete and put in the list, then any delete or put request that is being sent by the browser will immediately fail. Also, it also says list of allow the custom headers, like what all headers it needs. It's a very nitty-gritties that has been sent in that particular response header. And then only once it comes to the server browser saying that, okay, fine, we have the legitimate response from the server, then the browser sends the actual request to the server. So these are the key headers, as I mentioned in the earlier slide as well, which normally comes from the response that is being sent by the server. And now the thing is that how can we solve this course issue? So on the backend side, if it is being worked in express.js or Flask, then we have a course API where we need to install this, and that course has to be configured in a way that where it whitelists the browser request. Like, okay, I now allow http://example.com as a legitimate requester, or with the credentials, like it should pass me the credentials along with it. So for this particular setting, any extra requester who is not equivalent to http://example.com will not be given any data from the server side. And on the front end side, what we need to do is like we need to have proper headers. So whenever we are requesting the backend for any data, our API calls should have proper headers involved in it, included in it. And we shouldn't be using star for credential-based requests. Like it's not that, okay, if I send star, you just ignore the credentials and return us the data. It should not happen this way. So this is the common course thing that we always need to keep in mind when we are writing the API calls. Yes, that was from my side. Over to you, Violina.
Thank you so much. We don't have questions in the chat. Again, if anyone has questions for Dahnaya or Poulami, you can add it in the chat. But I wanted to thank you both for these amazing presentations and for breaking down these complex topics with clarity and enthusiasm. It's always a pleasure to have you as speakers in our JavaScript study groups. And thank you to everyone who joined today's session. Keep practicing and experimenting. Your journey into mastering JavaScript is just beginning. And feel free to continue on the conversation in the chat if you have any questions. If not, we will see you at the next session. Thank you.